So these are the test questions for your Chapter 4 test that was taken on November 13th, 2015. Directions: show all your work in the space provided and box your answers. Question number 1 says, triangle DEF is similar to triangle MNP. Which statement may be false? There's no picture. Draw a picture. DEF, MNP. Notice how P and D do not correspond. You also know that by the similarity statement. D is the first letter and P is the third letter. So that would be false. If you checked all of these, remember in similarity, corresponding angles are congruent and sides are proportional. Sides proportional basically means small over big, and they also have all the same scale factor. Question number 2, write a similarity statement for the triangles. I have 2 triangles. Notice how in similarity they don't have the same size, right? You have one small, you have one big. And here you can just fill in the information. H corresponds to E, so you can write 67 there. You can use triangle sum theorem and get angle G. And then you're with these angle measures now, that helps me write a similarity statement. C corresponds with F. So C, F, C, F, C and F, C and F. D corresponds with G because they both have 53 degrees. So D here does not correspond to G and A. D does not correspond to G because this is number 3 and this is the number 2 position. This is the number 2 position. This is the number 2 position. The only one that works is C. Question number 4, error analysis. Triangle FGH is similar to triangle JKL. A student was asked to list all the pairs of congruent angles, which they've done here, and write the ratios of the corresponding sides in a statement of proportionality. So if you didn't know what that means, there's the student work right there. Copy the diagram and correct the student's errors. There were 3 errors here. In the problem, G corresponds to K, second letter, second letter. The reason why I circled this because that was the error the student made. The second error was that H corresponds to L, third letter, third letter. And a lot of students miss this one here, is the middle one here. Notice how FG and FH, the numerator is all of the small triangle. The mistake they made is they should have wrote GH over KL. The scoring for that is if you found all 3 mistakes, I gave you 4 points. I gave you 3 points if you got all the sides correct or the angles correct, or you found 2 mistakes, and 2 points if you found 1 mistake. Question number 4. In the diagram below of triangle ABC, DE is a mid-segment. So if it's a mid-segment, I have congruent marks on both sides here of triangle ABC. DE is 7, so that's the mid-segment. AB is 10, and BC is 13. So if you just wrote down those numbers onto the picture, I gave you 2 points. Okay? I gave you 3 points if you just added up all the givens. So if you needed it, the word mid-segment, your equation is base equals 2 times the mid-segment. So for your formula sheet, if you want to add that to, you can. If I know this is 10 and these are congruent, that means that both of these have to be 5. Here this is 13. We already know that. And for the mid-segment, if this is 7 times 2 is 14. They want to know the perimeter of triangle ABC, not BDE. I actually made that mistake when I first did the problem really quickly. Then I recognized it is the larger triangle, so that would be 10 plus 13 plus 14. That'll give you a perimeter of 37 units. This is not area, so that shouldn't be there. Question number 5. Zoom out here. Solve for the missing variables. You have 3 missing variables here. This is a proportions of right triangles. So we talked about how you should draw the 3 triangles, and you should draw them and reorientate them. And notice how I have all the right angles here on the bottom right. So here's the first triangle. Notice how the easiest one is to find the absolute value. I mean, not absolute value. The hypotenuse, which is across the right angle. So there it is. Here on this triangle, the hypotenuse is Z. Notice how that on my picture. And in the third triangle, that is the largest triangle possible. The hypotenuse there is 4 plus y. So when I set up my proportions, you'll notice that I'm trying to look for a proportions that actually has the same letter or the same variable, and it has enough sides. Well, the only one that has that I chose was triangles 1 and 3. Triangle 1 has the hypotenuse and the short leg, x over 4. So x, the hypotenuse of triangle 1, over the hypotenuse no, try that again. I chose triangles 1 and 2. I see why. The reason why I chose triangles 1 and 2 is because the short leg and the long leg both have a number, and on triangle 2 I also have one side which is 6 and I only have one variable. So I'm trying to get it where there's only one variable. Here I can cross multiply. 4y equals 36, and you get y equals 9. So if you got that correct, or just one of the variables correct, I'll give you 2 points. I can take y equals 9 now and substitute that back into the picture. I chose triangles 1 and 3. I chose 4, let's see. If you put in 9 here, what did I do? Triangles 1 and 3. So I did 4 over x and x over 4 plus y. Cross multiplied, I got x squared, and here you get 4 times the quantity, 4 plus y. I know that x from the previous problem, I got the 52. I'll show you in a second how I got that. Divide both sides by 4, and you can also get y equals 9. So I think the one in here in red was a lot easier to solve for. Remember, this question was only 4 points. If you look at the first triangle, you have what type of triangle, class? You have a right triangle. How many sides do you have? You have 2 sides, given sides of a right triangle. Therefore, you can use what? You can use the Pythagorean theorem. When you solve for the Pythagorean theorem, here you get 4 squared, and this is 6 squared. That's 16 plus 36 gives you x squared equals 52. Take the square root of both sides, you'll get 2 radical 3. Now, it doesn't tell us round to the nearest tens or leave in simplified radical form, so I actually have both, if you had one of those. So that was x, this was y, and to get z, you can also use the Pythagorean theorem. Look at the triangle number 2. Once you solve for y to be 9, you have 6 and 9, then you just need to solve for the hypotenuse z. 6 squared is 36, 9 squared is 81, 36 plus 81 is 117. If you took the square root of both sides and used your calculators, you would have gotten 10.8. If you wanted to simplify the radical form, the factors are 3 times 39. The factors of 39 are 3 and 13. There's a pair that can come out and hold hands. That would be z is equal to 3 radical 13, or 10.8. This is probably the most difficult question on your test. Backside question number, did I mislabel it? Did. Number 7. Determine whether the triangles are similar. So that's a yes or no question, and then explain your reasoning. I gave you 3 points if you told me that the sides were congruent. They're not congruent, they're proportional. Okay, that is a big idea for the chapter. Or if you told me yes or no with no reasoning, I give you 2 points. So yes, triangles ABC is similar to triangle FHG by side-side-side similarity. Okay, how do I know it's side-side-side? Well, the common mistake or the low level of understanding is a student says, well, Mr. Ng, you have all the sides marked, and you have no angles marked. Yes, but you should have shown that the sides are proportional, which basically means you take from the big triangle to the small triangle, 16 over 8, 10 to 5, 8 over 4. You'll notice they all have the same scale factor. Now, the reason why that was important, I told you guys that on your quiz, is look at question number 8. Same thing. You have this picture. The student who didn't figure out the proportional sides or the scale factor, they just said, well, Mr. Ng, I see a side, I see an angle, and I see a side. Therefore, it's SAS similarity. Well, the answer is not. They are not similar. They're not similar because if you do 8 to 6, that gives me a scale factor of 4/3. 10 to 8 gives me a scale factor of 5/4, which means the sides are not proportional, which means you can't say SAS, SAS. Okay, so the answer was no. The triangles are not similar. Question number 9. There is a ravine. If you don't know what a ravine is, it tells you here in parentheses, a deep hollow in the earth on another edge of the park. You and your friend take measurements indirectly to indirectly calculate the width of the ravine. The figure shows your measurements, calculate the width of the ravine. This question was taken directly from, I think, one of our packets. I gave you 2 points if you set up the proportions correctly. I mean, 2 out of 4, the rest of the problem's wrong. I'm trying to give you guys some partial credit. So you'll recognize down here, this is your small triangle, and over here you can represent your big triangle. Now notice here, it's kind of small, in your paper you can see it probably better. This here represents X. X represents the width of the ravine. So you can do this problem in 2 ways. This is how I chose it. My small triangle is 6 and 15. Okay. This triangle, I decided to call it X plus 8 and 60. Now, for those in class, we talked about how you could call this whole length 8, and then you would have to call this whole length here X, and then subtract 8 at the very end. When you set up your proportions, it's you're doing a ratio of the sides, so 6 to X over 6 over X plus 8, and 15 over 60. You can recognize you can simplify the square root, 15 over 60 to be 1/4. Here you can cross multiply, you'll get X plus 8 equals 24. So for those who thought the answer was 24, I gave you guys 3 points. You had to subtract 8 and X is equal to 16. Question number 10, tell whether dilation is a reduction or an enlargement, then find its scale factor. A common mistake was just tell me if it's a reduction or an enlargement. So I gave you 2 points if you told me it was an enlargement. Remember, you're going from this little triangle here. You'll know that because it just says X, Y, and Z, and then over here it says X prime, Y prime, Z prime. Remember, the prime there is to let you know that something has happened to the original image. So you're going from 11 to 44. So it is an enlargement. The answer is, the second part is then its scale factor, the answer is 4. The reason why it's 4 is the distance here from this point of dilation is 11, and after you dilate it or enlarge it, you get 44, not 33. You don't do any subtracting there. 44 divided by 11 gives you 4. Okay? I gave you 2 points for the scale factor as well. Question number 11. Here you have an angle bisector. You'll know that because of these marks right here. Let's see if I can get it closer. Remember, we did something in class where you took the sides here, 20 over 24, and you did 7 over X. Okay, that was kind of basically a shortcut. So if you don't understand or memorize that formula, the other thing you can do is just recognize which one is small and which one is big. Well, the small triangle, you'll know, if you compare these two numbers, which one is smaller, class? The 20 is smaller, so label that the small triangle. So I have 20 over 24 and 7 over X. Remember, to try to reduce your ratios, you'll get 5 over 6, cross multiply, you'll get 42 equals 5X, divide by 5, and X is equal to 8.4. My favorite soda is Coke, or Coca-Cola.